Hi everyone. For this question, it is given that the examination marks of 100 pupils are given in the following tables. So you can see this is our group data. Why you call it group data? You can see our marks is category in 0 until 10. So it's not listing one by one. So this is our group data. So we need to find the Pearson coefficient of the skewness and describe the shape of the distribution. For Pearson coefficient skewness, we have two kind of formula. We can choose either one of it. So either one also can answer this question. But for this question, we will perform two kind of formula. So you can see based on this formula, the basic that we need here is mean and standard deviation. So for this group data, we need to find out what is our mean. Mean, it will be sum of fx over sum of f. So the number of students here indicate frequency. X here will be indicate our data since this is our group data. So X here represent midpoint. So 10, 0 until 10, midpoint we add up, divide by 2, 5. This one midpoint is 15, 25, 35, 45, 55, 65, and 75. So we can use our calculator to help us calculate our sum of fx, means f times x, then we total up, and total of f. So this kind of details we can find it in calculator. Therefore, in your calculator, you need to set into the mode of statistic, number 3. So use for one variable means one data, one kind of data about marks. So this is our x. And when we need this frequency column at the side here, we go to shift, setup. So means shift mode to find out your setup, going down, and find for statistic function to on the frequency column. Then we key in our data. For x is 5, 15, 25, 35, 45, 55, 65, 75. Then we key in our frequency, which is 2, then 12, then 25, then 29, then 15, then 10, then 4, and lastly, which is 3. So after we key in our data here, what we can do is we do AC and we want to get out all the option here, all the function about our statistic here. So for our calculator, for my calculator, I will press shift 1. But for if your new calculator, you just take the button of option. Once you find this calculator of option, you press your option, your function about statistic will become up. Alright, so you just press your button option. For my mode of this calculator, the old version one, we press shift 1 for statistic option here. So what we need is sum. We need sum fx. So number 3, I need sum of x here. So number 2. So my sum of x here will be 3540. And sum of f is number of data. Again, I press option, statistic option, and I go for number 4. I can get n. N is my number of data. So total data here equals to 100. So same as the questions here given, they said that is 100 student. Then continue. You find for the option, statistic option. Number 4, I can directly get the mean too. So option number 2, I can find out what is your mean, which is 35.4. Alright, so beside we need this mean, we need our standard deviation also. So standard deviation in our formula, it will be square root of 1 over sum of f minus 1, which is your n minus 1, bracket sum of fx squared minus sum of fx squared over n. So this is our standard deviation formula. So we plug in our value where sum of f is 100 minus 1 will become 99. Then sum of x squared, so I find for statistic option, go for sum, seek for x squared. So here we have 148300 minus sum of f we already have, divide the n, or in here it will be more suitable we put sum of f, total of frequency. So total of frequency is 100. Then we press calculator for the standard deviation. I can find it from the option, statistic option. I get number 4 here, which is sample standard deviation. It's not number 3. Number 3, this one is population standard deviation. This is sample. So our symbol is S. So here we have 15.24. So round off 236, I make it become 24. So now I can continue. So for the first formula that I need here is finding the mode. So finding the mode formula, it will be equals to L plus D1 plus D2 times C. So you need to find out what is your modal class, the highest frequency class, which is 4 on 30 until 40. So 30 until 40. Lower boundary you can see here is 30. Before this class also 30. So their boundary 30 plus 30 divided by 2, still 30. So D1 and D2, what is that? D1 and D2 is difference frequency before the class and difference frequency after the class. So this one different by 4, this one different by 14. So D1 is 4, D2 is 14. And C, size of the class. Size of the class will be upper boundary minus lower boundary. Upper boundary, you look at 40. After that also 40 means its boundary is 4 on the value of 40. Lower boundary, just now we found it 30 and 30. So lower boundary is 30. So size of the class is 10. Okay, so we figure out using our calculator here. So here we have 32.22. Alright, then we can apply to our Pearson coefficient skewness formula. For this formula number 1, Sk equals to mean minus mode divided by standard deviation 15.24. So here we have 0.2086. I round off become 9. Make sure our decimal here is more than or equal 3 significant figure. So as we get this Pearson coefficient in positive number, so what can we say about the distribution here? So after we get this value, our distribution, if you positive number, means the distribution is skewed to the right or positively skewed. Skewed to the right. So or positively skewed. So let's say we apply another formula. Let's say we are using the formula that finding median. using median, formula number 2. So we need to find out what is our median first. Median, we need to find out the median class. Median class will be location n over 2. So 100 over 2 equals to class at the data of 50. So we find out what is our BF here, cumulative frequency. This is 2, add up, 14, add up, 39. So 39 plus add on 29, it gives us 68. So I think I can stop here. So our median class also happen at 30 until 40. This is my median class. So your lower boundary is 30. So L, position, minus cumulative frequency over own frequency times size of the class. So lower boundary is 30. Position is 100 divided by 2, 50, minus this cumulative before the class. So cumulative before the class is 39. Divide by its own frequency. So this class frequency is 29. And the size of the class just now we already calculate because we are using the same classes here. So the model class also equal to our median class here for this situation. Therefore, we can find out what is our median. So when I apply for the second formula, percent of coefficient skewness, 3 times mean minus median over the standard deviation, 15.24. So we apply the formula number 2. So we're still getting positive number. So 169. So if you want to round off, it become 17317. Alright? So our conclusion still same. So when you have positive value, means the distribution is skewing to the right or positively skewed. So from this question, we can see although we use different formula, our reading will be different, but the conclusions here will be pointing us to the same direction, which is this data distribution are skewed to the right. They are positively skewed. So different formula will give you different value, but conclusion for the distribution, it will be same. So that's all for this question. Thank you for watching.